Yes, you can start.
Okay, so I will be presenting midpoint milestone for Kaupang DEX for zkIgnite Node 3. So what kind of milestones we pledged to work on? Let's take a look at that first. So the things that we wanted to build during the first 1.5 months was the XYK wallet and governance implementations. So for XYK, we reworked the XYK implementation we had from navigators and we wrote a new one that also comes with a completely new XYK UI. It also comes with liquidity provisioning, that's add and remove liquidity, and pool creation UIs that connect to the newly created XYK runtime. We also provide simple routing between XYK pools, so we'll see that later in the demo. And we also have support for trade fees. So if you're a liquidity provider, the standard practice is that whenever a trade is made in the pool, the trade is a little bit less favored towards the person who is doing the trade, and you basically deduct a small percentage or a fraction of a percentage from the trade, and you keep that amount in the pool. And that's why, or that's how the liquidity providers make money. So we have implemented all of that plus UIs for it. Then when it comes to the wallet, so we obviously have like a way to keep track of balances on the L2 itself. Plus, as part of the new XYK UI, we also have like a little minimal sidebar wallet and a transfer implementation as well. So it will be able to, it handles things like, connecting the wallet, switching the accounts in Oro, showing you all the balances that you need to see, plus a separate UI for allowing you to transfer balances on the L2 itself. When it comes to the governance, we didn't want to build any UIs before the midpoint for the governance. We only designed a governance runtime for the DEX itself. The main goal here was to provide a way for token holders on the L2 to mainly Mina token holders on the L2. So the point of the governance was to allow the token holders on the L2 to vote to which block producer the Mina blocked on the L1 bridge contract is going to be delegated to. So we designed a quite elaborate governance structure and also implemented it. You should be able to see that in our repo. So at the rest of the presentation, I will also walk through the details of how the governance actually works. So let's dive right into it before we go into the demo of the XYK and the wallet. I want to talk a bit more about the governance itself because there's quite a lot going on. Plus, there's obviously no UI for it yet. So let's talk a bit more about how the governance actually works. So there's this concept of a governance lifecycle, which consists of 3 governance periods. Could be 3, could be 4, depending on how you configure it. But like by default or for the testing purposes that we did, we use 3 periods. By design, each period could be, for example, 1 week. Therefore, each lifecycle would be 3 weeks. For the testing purposes, we have every period equivalent to 1 block so that we can just test it really quickly. It's just a matter of config in the end. Both the periods and the overall lifecycle is advanced automatically by the protocol. So we have not a runtime, but a protocol implementation that checks if the period or the lifecycle needs to be advanced. And that happens essentially every block by design. In the current implementation, it happens with every transaction, but that's more or less equivalent. When the last period of the lifecycle ends, the whole lifecycle resets back to the starting period. So if you go through periods 1, 2, 3, and you're at the end of period 3 and it's supposed to advance again, you won't go to period 4, but you will go back to period 0, but the ID of the lifecycle will increase. So to participate in the governance, you need some form of voting weight, right? So as I've mentioned, the point of this concrete governance implementation was to allow people who hold Mina, that is bridged from the L1 to the L2, to vote with their L2 Mina balance about to whom the L1 bridge contract will be delegated to. So therefore, we determine the voting weight by your respective token balance of Mina on the L2. We can also, in the future, down the line, not now, extend the governance implementation to take your LP positions into account. So you have your Mina on the L2, you provide liquidity for a pool. That means you still have the Mina, but it's like in the pool and it's actively being traded. And the snapshot or the representation of your tokens in the pool is your LP token balance. So we also have plans to allow LP token holders to participate in the governance as well, because that's really important. I mean, all the incentives are aligned there. They're long-term, logged into the protocol, so they should be able to vote, same as people who have unlocked Mina balances. So the way we determine voting weight, the approach we selected is called conviction voting. So anytime you want to interact with the governance, if it's proposing a proposal or voting on a proposal, you need to have sufficient voting weights to be able to do that for each step. We determine the voting weight by taking your Mina balance and multiplying it with the conviction multiplier. And the conviction multiplier is determined by the duration for which you lock your balance. The reason why we use this sort of voting mechanism that is powered by locking your balances is because we believe that locking your balance signals a commitment to the health of the project itself. Therefore, it's definitely, I mean, at least in my eyes, better than just using snapshot balances, because if the result of the vote is like contributes negatively to the overall health of the project, then your tokens being locked, they potentially also will decrease in value. So like your votes should be worth more. This also allows us to increase. So if you're a user and you want to vote, you can also increase your voting weight by locking your tokens for a longer period than necessary. The minimum amount that you should be locking your tokens for is the duration of like one life cycle. So if it's 3 times 1 week, then that would be 3 weeks. If you lock it for twice as long, so 6 weeks, your conviction voting multiplier would double. So your voting weight would be doubled essentially, at least in the current implementation. Of course, all of these numbers are a matter of config, and we can adjust them as necessary. So if you want to propose a proposal, you obviously need to have a minimum voting weight locked. That is to prevent proposal spam. If anybody would be able to just throw out proposal without having a way to filter or indicate that you have a vested interest in the protocol, that would be difficult, and we would probably get a lot of spam. So we wanted to prevent that. Every time you want to propose a period, every time you want to propose a proposal, that can only happen during the proposal period. In this concrete example with the set delegate proposal, the proposal is essentially specifying the delegate address that you want to propose. Plus, you obviously need to have a balance lock to be able to do that. Voting on that proposal can only happen in the second period, which would be the voting period. If you want to vote, you again have to create a balance lock for a sufficient time period. As we discussed, you have the minimum time period, and then you have the multiplier if you lock for longer. The votes are completely public. We believe that this should be transparent. And the votes are summed up every time someone votes, like the runtime takes care of that. And then once the voting period is over, we enter the execution period. And during this period, any proposal can be executed, assuming that it matches like successful proposal criteria, right? So the basic things that we have implemented is a way to measure if you have reached quorum that relates to a snapshot of a total supply at the time when the voting began, or something like that. I'm not exactly sure if I am explaining it correctly. I would have to look at the code again, but essentially we measure the yes and no votes against the quorum to measure participation. Plus, we also measure majority or supermajority, again, depending on the config that you choose. That means that a lot more people had to vote yes than no for the proposal to pass. And if the proposal is passing, then you can execute it during the execution period. This is essentially where the governance implementation ends, because what the execution does, it taps into something that we provide out of the box from ProtoKit. It taps into the cross-chain messaging architecture that we have, and it dispatches, or at least registers a message at this point that you are trying to dispatch a message to the L1 that would set the delegate on the bridge contract. So that's where the governance implementation ends, and that's where the remainder of the messaging protocol is then implemented by ProtoKit under the hood. So just to recap, there's a proposal period where you can make a proposal. You need to have a sufficient balance to do that. Then there's a voting period where everybody can vote. The yes and no votes are summed up. And then in the execution period, we check quorum and supermajority requirements in order to actually execute the proposal if it's passing. And the result of executing the proposal is just registering an outgoing message from the L1, from the L2 to the L1, which is then picked up by the rest of the framework as part of our cross-chain messaging architecture. Okay, so for the rest of the things, that would be XYK and wallets. I have a video demo for you. I mean, we could also do it live, but I don't want to risk it breaking or anything. So let me just bring it back here. I hope you can all see my demo. And I'm just going to hit play and tell you a little bit more about what the demo is doing. So we load up the UI of Kaupang. We have a sequencer running the protocol in the background. We connect the wallet from Oro. You can see the wallet on the right side. You see the connected wallet, and you see your current balances. Then at the bottom, you see some additional information like the current block of the chain, or the L2 or the app chain, or however you want to call it. You see that the network I'm connected to is the locally run sequencer on my computer, and all the balances are essentially zero. What I'm going to do next, I'm going to interact with the faucet multiple times to get some testing balances, plus you can see the notification for these transactions. So first transaction was successful. We got some tokens from the faucet, and I think we'll do 2 more. There you go. So now we have those tokens, and we can go and create our first pool. The first pool will be for Mina and DAI. We'll specify the amounts of the initial liquidity in the pool. And in return, we will get LP tokens that represent our position in the pool. So we create a pool, the transaction is successful, our balance decreases, but the balance of the LP token increases, and we can see that in the wallet. We'll create a second pool between DAI and BTC. Again, we provide some initial liquidity, get the LP tokens, sign the transaction, send it out to the sequencer. There we are. So now we have LP tokens of both positions that we have, and we can start trading in the XYK UI. If you select Mina and DAI pool, you see that the trade happens directly. If you select trading between Mina and BTC, it has to be routed from Mina to DAI and from DAI to BTC. That is the simple routing. You input your amounts, the price gets automatically calculated through multiple of these pools. You sign the request to make your trade. Then your balances will change, assuming that the trade is successful, and you are good to go. The thing you should also notice is that if I go back in time, if you're trading between Mina and BTC, you input the amount, the output amount is calculated, that is subtracted with the fee that's supposed to be paid for the liquidity provider. And then once we make the trade, the amount actually changes, because that's how XYK pools normally work. So the liquidity in the pool has changed, or actually in both of these pools. So therefore, the amount is now going to be different, assuming that you are trading or putting in the same amount of tokens. So that's how even Uniswap works, for example. And we see the balances change once the transaction is successful. What I wanted to do next is copy out an address of a different account that I have in Oro, but I believe that Oro was crashing at the time, but you will be able to see it anyways. So I'm sending 500 Mina from my account to this other account that I have in my wallet. I'm gonna do the transfer. And now when I try to switch the account to my other account, Oro crashed, so I just had to restart it as part of the demo. So yeah, we'll just reload Oro and we will be back in business. Yep, there we go. Put in the password and switch the account. Now the UI is not responsive since the wallet has crashed, so we will have to reload it. Connect the wallet again. And we can see the account where we have sent the Mina back to. And we can also switch between the accounts, and the UI will automatically reload. So that was a successful transfer. We transferred from the original account to a separate account, and that signifies the end of the demo. Of course, you could also go back, add liquidity again, remove liquidity, which will give you the tokens back, continue trading how much you want, or continue transferring, and the app chain would just continue operating. Okay, I believe that's it for my demo. Thank you for listening. If there are any questions, I would be happy to answer.
Yeah, thanks, Matej. Do we have any questions from crowd? Yes, one question in the chat.
Does it have L1 settlement? So the demo that you saw was using the local sequencer, and it was running as a sovereign chain. So it wasn't settling anything to the L1, nor bridging anything back from the L1. Of course, I mean, as time progresses, we will have a full integration with Berkeley or DevNet, and you will be able to even bridge the tokens as well.
Any more questions? Okay. Kadir, yeah. Kadirjan, do you have a question, or it was just... Okay, no worries. So then I'll stop the recording. Thanks again, Matej, for the presentation.